Imagine feeding a single book draft into an AI.
Hmm.
Instantly, you get 5 completely different reviews back. One review is from Linda. She's a retired teacher, brand new to AI. Another is from David, a corporate executive.
Right.
It's the exact same text draft, but you get completely distinct parallel perspectives. It feels like actual magic, but it's really just smart engineering.
It really is. It's a fascinating shift in how we interact.
Okay, let's unpack this. Welcome to our deep dive today. We're exploring the hidden power of Claude Code's subagents.
Yeah.
We're going to look at what they actually are. We'll see why they save massive time and money. Then we'll help you build a custom plan roster. We'll also set up vital safety guardrails you need. And finally, we'll scale up to dynamic workflows. I'm joined by our expert guide today. Let's dive right in.
Hey there. I'm incredibly excited to get into this topic.
That opening scenario with the book reviews sounds incredible, but I want to understand the mechanics here first. How does that parallel work actually happen behind the scenes?
Well, it's a beautifully simple system of delegation. You can think of the main chat as your boss. The subagents are the workers.
No.
You only ever talk directly to the boss. Subagents don't talk to you directly either. They don't even talk to each other. They just do their job and report back.
So it's kind of like a bustling restaurant kitchen. The main session is the head chef talking to customers. The subagents are prep cooks chopping onions in the back.
Yeah, that's a perfect analogy. And setting up your kitchen this way gives 4 massive benefits. The very first one is keeping a pristine context window. Long AI chats get polluted incredibly fast.
Yeah, because you make the AI read up on stuff, like reading about Firefly's AI just for a quick summary. That junk stays in its memory forever. Nobody wants that useless noise clogging up the conversation.
Exactly. Every single token matters.
Okay.
The second benefit is a drastically lower overall cost. You use the really smart Opus model for planning, but you spin up cheaper Haiku models for heavy reading.
That makes perfect financial sense right there. You don't pay a head chef to peel potatoes.
Spot on. The third benefit is pure parallel work. You can review 15 book chapters at the exact same time.
Oh.
You could research 5 different competitors all at once.
That speed is just incredible. I know trying 15 chapters normally makes the AI hallucinate, so parallel work clearly fixes that issue. But what about the actual quality of the feedback?
That brings us right to the fourth huge benefit. You get a truly fresh review every time. Subagents always start with completely blank memories. They give you honest and unbiased feedback. They aren't trying to be agreeable.
Is context pollution really that big of a deal in normal workflows?
Yes, it's a massive problem. Forcing one model to hold every file degrades its focus. It loses its logic over time.
So crowded memory makes the AI lose focus and logic.
Exactly.
The kitchen analogy makes total sense to me. I definitely want those prep cooks saving me time. But if I'm the head chef here, how do I actually hire them? How are they given their specific instructions?
It's surprisingly simple under the hood. A custom subagent is literally just a single markdown file. You usually store it in a hidden .Claude agents folder.
Wait, hold on. Just a standard text file? I assumed we were talking about complex Python scripts here.
Nope, just a standard markdown file. It has 2 completely distinct parts. The top part is the YAML front matter.
Let's pause for a second. Define YAML front matter for us.
A small settings block at the top of a file.
Got it.
It holds the name and the trigger description. It also holds the model you want to use.
Just basic configuration then. So what is the second part of the file?
The second part is the main body. That's the actual workflow. It tells the agent exactly how to think. It lists the exact steps and the required output format.
I read that Claude uses progressive disclosure here. Why is that specific feature so important?
Think about it like RAM on your computer. If Claude loaded massive instruction sets every time you said hello, it would just grind to a total halt.
Right.
Progressive disclosure means it only reads that tiny trigger description first.
I see. So if the trigger matches, it loads the full body. That saves a massive amount of processing power.
It's exactly right. Let's look at a concrete example to make this real. We call it the plan roster.
I really love that name.
It's a phenomenal tool. The trigger description is kept remarkably simple. It just says, to use this agent to critique a plan.
I have a confession to make here. I still wrestle with prompt drift and misfires myself. Beat. It's frustrating when the AI just ignores your tools. Here's where it gets really interesting, though. People fall into a psychological trap when building these. They make those trigger descriptions way too long.
They really do. It's a very classic mistake. A long description confuses the whole routing system. You must keep it remarkably short and punchy, Put the real heavy lifting down in the body instead.
Right. The body is where you get highly specific. You tell the agent to find the absolute weakest points.
Yeah, and you tell it to explain what could go wrong. You want it to be totally ruthless.
What happens if the subagent just doesn't fire when I want it to?
Well, that's called a misfire. It usually means your description is too vague. You fix it by trimming the description down.
If it ignores you, make the trigger description shorter and sharper.
Precisely.
Okay, we know how to build one now, but once we write this text file down, where do we actually put it? We don't want these prep cooks getting lost.
You need to understand skills versus subagents first. Skills run directly inside your main session context. Subagents run in a separate, fresh session entirely.
But they aren't totally isolated from each other, right? They can actually work together.
Absolutely. A subagent can actually invoke a skill.
Right.
Imagine spinning up 5 subagents at once. They all use a LinkedIn research skill simultaneously.
That is an incredibly powerful combination. It's like giving your prep cooks power tools.
It really is. Now, for storing these files, you have 2 main choices. You have project-level folders and global-level folders.
Let's break down why you'd use one over the other.
Project-level agents live inside your specific code repository. They're best for dedicated team workflows. Think about a strict security reviewer agent.
That makes total sense, because when you push the code to GitHub, your entire team gets that specific agent automatically. It stays directly with the project it belongs to.
Exactly. Global agents live in your personal user directory instead. You use those across all your different projects. A personal writing reviewer is a great example.
If I put an agent in the wrong folder, am I stuck?
Not at all, since they're literally just standard markdown files. You can just drag and drop them to a new folder later.
They are just text files. You can move them anywhere, anytime.
Exactly right. It's highly flexible.
Midroll sponsor read placeholder.
All right, let's get back to it.
Okay, we have an army of cheap parallel workers now. We know how to build them and store them. But if we let them run wild, they could completely break our systems. We need to talk about security guardrails.
Security is absolutely non-negotiable here. You have to adopt a zero-trust mindset. If an AI can touch something, assume it might.
That is a slightly terrifying but deeply realistic rule. How do we actually enforce that zero-trust policy?
You must use strict tool restrictions. Always use read-only tools for your review agents. Our plan roaster doesn't need permission to write files. It only needs to read your plan and return feedback.
So you only give edit access when strictly necessary. Never do it by default.
Exactly. You also have to carefully limit your MCP access.
Let's define MCP servers for the listener really quickly.
Tools letting AI talk to your private databases and apps.
Got it. So you don't give a writing critic database access.
Please don't. That's a recipe for absolute disaster. Imagine a rogue subagent accidentally dropping your user tables. You also need to enforce max turns in your settings.
What does the max turn setting actually do?
It firmly caps how long an agent works. It prevents them from getting stuck in infinite loops, and it stops them from burning through your wallet.
What about downloading community agents from public repositories? People really love sharing their custom setups online.
Be incredibly careful with those. They're still just basic instruction files. They can easily contain malicious prompt injection or data leaks.
You know what I think is a brilliant idea here? Building an AI agent specifically to act as a bouncer. Its entire job is just to inspect third-party agents.
That's a fantastic safety practice. Build a read-only verifier subagent just for that exact purpose. It reviews the code before the boss ever sees it.
Why isn't a prompt like, "Do not edit files" enough to keep an agent safe?
Because text instructions can be ignored or hallucinated away. Real permission limits physically block the AI from taking dangerous action.
Never trust a polite request. Use hard permission blocks instead.
That is the golden rule of agent security.
So our system is safely locked down and isolated now. How far can we actually push this boss-worker relationship? What is the true ceiling here?
We can push it remarkably far. Your main session can spin up massive numbers of subagents. We're not just talking about 3 or 5 agents.
We're talking about serious dynamic scale.
You can deploy 40, 100, or even 200 agents, and they all run in perfect parallel simultaneously.
I've seen developers trigger this by typing ultra code. It's kind of become a meme online.
Yeah, that's a dramatic trigger phrase people use. The use cases for this scale are completely wild. You could review a massive legacy codebase instantly. You could test dozens of experimental bug fixes all at once.
Or review a massive 1,000-page book chapter by chapter. 2-sec silence. Whoa, imagine scaling to 200 agents testing code base fixes at once. That's a whole tech company inside your laptop.
It really is. It fundamentally changes how fast you can iterate. But there's a very serious warning here. This burns through your session limits incredibly fast. It eats through your API tokens like crazy.
Yeah, I can see how that gets expensive quickly. If you aren't paying attention, that's a massive bill.
Exactly. Don't use dynamic workflows for small, trivial edits. Save this incredible power for the truly massive parallel tasks.
When should I absolutely avoid using a subagent or dynamic workflow?
Avoid them when the task is tiny, or if it depends heavily on previous chat history, or if it requires constant back-and-forth conversation with you.
Keep small, highly conversational tasks in the main chat window.
Exactly. Don't overcomplicate the simple stuff.
So, stepping back from all the technical execution, what does this all mean for us?
If we connect this to the bigger picture, the core philosophy here is delegation. You have to change how you think. Ask yourself a simple question. Is this task going to dump a huge pile of text into my chat window? Stuff that I'll never actually read again.
If the answer is yes, you delegate it immediately.
Exactly. Keep the boss smart on Opus. Make the workers cheap on Haiku. Keep your context completely clean. And start small by building highly specific, narrow specialists.
We're moving into a really strange new era. You're no longer just an AI user typing prompts. You're an actual AI middle manager right now. Think about the implications of that for a second. What happens when your subagents eventually get the ability to hire their own subagents? At what point do we lose track of the bureaucracy? There's going to be this massive invisible bureaucracy happening inside our own computers.
Beat. That is a mildly terrifying but utterly fascinating thought. It changes the whole definition of personal computing.
It really does. I want to challenge you, the listener. Go into your .Cloud Agents folder today. Just write one simple read-only subagent. See what happens when you delegate a tiny piece of your workflow. Thanks for joining us on this deep dive. Let those prep cooks get to work.